Hi guys, good morning. This will be the last topic for Unit 9, and it's one that even though we're going to cover it in geometry, you're really going to see it much more often in pre-calc for those of you guys who take that in about 2 years or so, alright? This is something that was not originally on the geometry EOC, but it will come back later. And for those of you who ever take the SAT math subject test for entrance into competitive colleges, universities, this is something that they could ask questions on, alright? So we will cover it. Now the law of cosines, which is our topic for today, is very interesting. And it's interesting because we've actually used it before without ever realizing it. Most of us recognize this equation right here. Alright, we usually say a squared plus b squared, but in this case, I'm just going to write it in this form. What theorem is that? That's the Pythagorean theorem, isn't it? Now the Pythagorean theorem, believe it or not, is itself actually a special case of the law of cosines. It's a special case of the law of cosines because it only applies to right triangles. The law of cosines, by contrast, will apply to any triangle, whether it's acute, obtuse, or right, and its equation is as follows. C squared equals a squared plus b squared minus 2ab cosine c. Now I know that there are 3 spaces in your classwork packet, okay? Well, by the way, I think I probably should have said where we are. We're on your classwork packet, page 15. Once again, that's the Unit 9 classwork packet, page 15. I know there are 3 spaces there, okay? Don't freak out on me. You only need to write this one equation, and here's why. Unlike for the Pythagorean theorem, it doesn't matter what you call A. It doesn't matter what you call B. It doesn't really matter what you call C. The only thing I would suggest is that whatever you're looking for, whether it's a side or whether it's an angle, I would strongly suggest that you actually call that C. This would be the side, and this one over here would be the angle, alright? Now this is actually really a giant game of plug and chug, alright? So for those of you guys who love calculators, this should be one of your favorite lessons ever. To see how this works, let's take a look at question number 1. Once again, what number? Number 1. Okay, so question number 1 looks something like this. I apologize in advance if my drawing is bad. Most of you should be used to it by now, right? Because you like to criticize me all the time. Yeah, whatever. Okay, so this is 65. That's 7. That's 12. And this is x. Okay, so the first thing I'm going to do is I'm going to just do some labeling here, alright? The one that I want, I'm going to call that C, just so it's easy for me to know where I'm plugging in, right? And then the ones that I have, I'm going to call this side A. Why? Because I feel like it. I'm going to call this one B. Why? Because I feel like it. And because this angle is across from the C, I'm going to call this big C, which is a fancy way of saying the angle that corresponds to C. So now, here's what I'm going to do. I'm going to write out my law of cosines, which says that C squared equals a squared plus b squared minus 2ab cosine C. Oh my god, what a hot mess, right? Well, actually not, because guess what? All you have to do is plug in. So I don't know C yet, so I'm going to leave that as C squared. Do I know what A is? Yes, A is 7, so I'm going to say 49, because 7 squared is 49. Do I know what B is? Yes, I do. B is 12, and 12 squared is 144. Now, 2 times A times B, well, 2 times 7 is 14, right? And then 14 times 12, let me work that out over here. Most of you will use your calculator. I'll try not to judge you too harshly. All right, so that's 168 cosine C. Okay, so in order to solve this equation, first thing we got to do is combine some like terms, right? I got some like terms right here. So I got C squared equals, let's see, that's 193, I think, minus 168 cosine C. And I actually know what C is, so I should have plugged in right there my 65. Okay, can you guys actually help me figure out what this is right here? What is 168 cos 65? Well, let's do that in the calculator. So 65, hit the cosine key. Then I'm going to times by 168. All right, so that's going to give me minus, at this point, it's actually clear that's going to be around 71, so I'm just going to round it, all right? I know I told you not really to do that kind of stuff, but in this case, because it's so close, it's not really going to make much of a difference, all right? So what is 173 minus 71? Well, I would think that it's 102. And last question, how do I get rid of a square? What's the opposite of squaring? How many times have I asked that before? You take the square root. So in this case, the rad 102, let's see what that would be. That would be about 10.1. So C is around 10.1. And that's not unreasonable, right? Because this is, it's not too big, not too small. It's between the other two sides. So I think we're good, all right? So what I hope you saw there is this was really just a giant game of plug and chug. The important thing is that whatever you're looking for, whether it's an angle or whether it's a side, make sure that that's what you call C. It does not matter what you call A and B, right? With Pythagorean theorem, but the rules were a little more strict. All that I ask is that for this particular case, you call C whatever you're looking for, all right? Now, this is pretty easy when we're looking for a side, right? Where it gets a little bit trickier is when we're trying to find an angle instead. So let's take a look at number 5. Once again, which one are we looking at? We are looking at number 5. All right, so let's take a look at question number 5. Now, number 5 looks something like this. All right, I think it's still an acute triangle. Well, of course, my eyes could be failing. Wouldn't surprise me. All right. All right, that's 12, and that's x. Okay, so as I said, the only important thing to label is what's C. Whatever I'm looking for, I'm going to call C. So I'm going to call this big C for the angle, little c for the side, and I'm just going to call this A, I'm going to call that B. Does it matter that 7 is small? No, not at all. I do not care. Okay, it does not matter. So now, here's what I'm going to do. I'm going to write my equation. C squared equals A squared plus B squared minus 2AB cosine C. All right, so let's start plugging in. C is 7, so 7 squared is 49. A is 12, and 12 squared is 144. B is 11, and 11 squared is 121. Then, let's see, 2 times 12, that's 24, and 24 times 11 is 264. So minus 264 cosine C. All right, let's do a little tiny bit of combining like terms here, okay? So 144 and 121, that's going to make 165, I believe, minus 264 cosine C. Okay, now notice, my ultimate goal is to get C alone, right? But right now, it's inside a cosine function. So before I can get C by itself, I got to get the cosine C by itself, all right? So to do that, I'm going to subtract 165 from both sides. So I'm going to do minus 165 on both sides, and that's going to give me, let's see, on this side I'm going to get negative 116 equals negative 264 cosine C. How do I get rid of a multiplied negative 264? Well, I'm going to divide both sides by 264, and so I'm going to get this, 0.439 4-ish, right? I know it's a repeating decimal. I can leave that, equals cosine C. And then what I can do, because I'm not trying to find the angle, I'm going to have to use not regular trig. What kind of trig do I have to use? Anyone? Anyone? Oh my gosh, inverse trig. So I'm going to hit my second key, the big green button, and then I'm going to hit cos, and I'm going to get 63.9. All right? So in this particular case, this angle right here is about 63.9 degrees. All right, 63.9 degrees. Okay, so with that being said, I want you to notice something important. Once I find one angle, the entire rest of the problem could be solved by using law of sines first, followed by triangle sum theorem. All right, that's the big picture in all this. We're trying to give you guys tools so that when confronted with a triangle problem, you can apply first law of cosines if you don't have any angle side pairs, followed by law of sines to find possibly another missing angle, and last but not least, triangle sun theorem to fill in the rest of the information. Okay? Now again, this is something that was really not heavily emphasized in geometry, right? It was not going to be on your EOC. However, it's something that you guys will be seeing in pre-calculus and you will need for the SAT 2 subject test if you guys choose to apply to schools out of state in a couple of years.